If you like scroll through the news lately, you'd think the electric vehicle revolution just drove straight into a brick wall.
Oh, absolutely. The doom and gloom is everywhere right now.
Right. Headlines are screaming about stalling sales and consumers getting cold feet.
Yeah, and the public infrastructure is just completely crumbling.
Exactly. But if you actually look at the physical copper and steel being put into the ground right now, it's wild because the numbers tell a completely different story.
They really do.
Yeah.
I mean, 2025 wasn't a slowdown at all.
No, it was like the biggest, most aggressive deployment of EV infrastructure in history.
It's a massive disconnect.
Mhm.
We have this public perception that is, zigging heavily toward pessimism, but the actual industrial reality is violently zagging toward expansion.
Yeah.
Like the companies putting up the capital, they're making entirely different bets than the op-eds would have you believe.
Which is exactly what we are decoding today.
Yeah.
Welcome to the deep dive, by the way. Our mission today is to move way past those breathless headlines.
Right. We need to look at how we are actually powering this transition.
Yes, and to do that, we've pulled a stack of sources for you. We've got comprehensive industry analytics from Perrin, covering the entirety of 2025 and the first quarter of 2026.
Which is great data.
Oh, it's incredible. And we're also looking at the brutal corporate reality through the 2025 annual report, specifically the Form 10K of a major network operator, Blink Charging.
Yeah, that one is an eye-opener.
It really is. And to top it all off, we're tracking this fascinating shift toward off-grid infrastructure with some recent moves by a company called Exos.
So we're kind of covering the whole spectrum today.
Exactly. So
Yep.
let's just jump right in. Let's start by looking at what is actually going into the ground, because the parent data is, well, it's pretty staggering when you contrast it with the public mood.
Staggering is definitely the right word for it.
Yep.
In 2025 alone, we saw a 30% year-over-year increase in DC fast charging infrastructure nationwide.
Wait, 30% in 1 year?
In a single year. They deployed 18,041 new ports. Yeah. To put that in perspective, I mean, that is a massive acceleration in heavy, high-voltage equipment.
Right.
And, the critical part here is that demand didn't just passively absorb this new capacity, it actively matched it.
Really? So people are actually using them?
Oh, yeah. The networks recorded an all-time high of 141 million charging sessions in 2025.
Okay, so wait, a 30% increase in the physical hardware and a proportional boom in usage.
Yep.
I feel like that completely shatters the narrative that these new stations are just, sitting empty in deserted parking lots.
Exactly. People are actually plugging in. And the momentum didn't just stop on New Year's Eve either.
Right, because we have the Q1 2026 numbers too.
We do, and those show another 3,387 ports coming online just in that first quarter.
That is just huge. But, it's not just the sheer volume of stations that caught my eye in this report.
Right, the footprint is changing.
Yeah. The stations themselves are physically mutating. They are getting so much larger.
They definitely are. I mean, Tesla has always been the heavyweight champ of station size, right?
Oh, sure, they build those massive plazas.
Exactly. They average about 12.2 ports per location. But historically, the non-Tesla networks, they would just drop like 1 or 2 chargers in the back of a grocery store lot and just call it a day.
Right, way out by the dumpsters usually.
Yeah, exactly. But that era is over. The non-Tesla networks are sizing up too. They jump to an average of 4.6 ports per station.
And they're standardizing around speed now, right? Because the Perrin data showed that 55% of all new non-Tesla ports deployed are high power,
Yes.
meaning 250 kilowatts or more.
Right. And let's actually pause here and define what that means for you, the driver.
Yeah, that's a good idea.
When we talk about kilowatts or kW, we are basically talking about the speed or the pressure of the electricity flowing into the car.
Okay, so if an older, say, 50 kilowatt charger is a garden hose.
Then a 250 kilowatt charger is a fire hose.
Fire hose, got it.
That is a great way to visualize it. We're moving entirely away from the older hardware because drivers expect to plug in and get a meaningful charge, say, adding 150 miles of range in the time it takes to just run inside, use the restroom, grab a coffee.
Right, nobody wants to wait around for a 50 kilowatt trickle anymore.
Exactly. And to achieve that fire hose effect, you have to bypass the car's internal components,
Okay,
which is the fundamental difference between level 2 charging and DC fast charging.
let's unpack that difference a bit because it kind of dictates how this entire industry operates, doesn't it?
It really does. So the battery in an EV, it stores DC, or direct current electricity.
Right.
But the power grid itself transmits AC. alternating current.
Okay, so they don't match.
Right. So a level 2 charger, the kind you might have in your garage or see at a hotel overnight, it just supplies AC power.
Gotcha.
And then the car has to use its own heavy, expensive onboard converter to change that AC into DC before it can go into the battery.
Which creates a bottleneck, I assume.
A massive bottleneck.
Yeah.
The car can only convert so much power at once without overheating.
Oh, that makes sense.
Right. So a DC fast charger, on the other hand, it does all that heavy AC to DC conversion inside the massive cabinet sitting on the sidewalk.
Oh, so it just skips the car's converter.
Exactly. It bypasses the car's internal converter entirely and fires direct current straight into the battery pack.
And that's how you get those 250 kilowatt speeds.
You got it.
Which brings up the physical connection itself, the
Yeah.
whole plug war, because this directly impacts you if you are planning an EV road trip anytime soon.
Oh, for sure.
Like, the headlines have been declaring that everyone is switching to Tesla's plug standard, the NACS plug, right?
Yes.
And that the older, clunkier standard CCS is just completely dead. But Perrin's numbers show a completely different reality on the ground.
Yeah, the headlines were wildly premature on that one.
I mean, NECS is growing, right?
It is. It hit about 21% of new non-Tesla deployments in Q1 2026. But CCS still makes up 73% of those newly built non-Tesla ports.
73%.
Yeah.
So that means if you're driving across the country this summer, you are still going to be playing, basically, adapter roulette.
Pretty much, yeah.
You might pull up to a station hoping it has that sleek little NACS plug, but statistically, nearly 3/4 of the time, you're going to be digging that massive, heavy CCS adapter out of your trunk.
Oh.
Probably in the rain.
Oh, it's always in the rain.
No.
But yeah, this hardware transition, it's going to be a multi-year slog.
It just takes time.
It's unavoidable friction. It takes years for supply chains to retool and for old factory inventory to clear out.
Right.
But, once you actually get the car plugged in, the experience is definitely improving.
Is it?
Yeah. The nationwide average for reliability, meaning the charger actually works when you swipe your app, is sitting at a highly respectable 93.5%.
Okay, that's reassuring. But how often they are being used is kind of a different story, isn't it?
Yes, utilization is the tricky part.
Right, because the utilization rate, which is the percentage of time a charger is actively dispensing power into a vehicle that held steady at around 16.4% through 2025.
Right.
But then in Q1 2026, it dipped down slightly to 15.6%.
Yeah, and we really have to look at the geography of that dip to understand it.
What do you mean?
Well, in mature markets like California or, the Washington, D.C. metro area, utilization is screaming past 25 or even 30%.
Oh, wow, okay.
Yeah, the national average is just being dragged down because companies are building heavily in emerging markets.
Mm.
Places where the EV adoption curve is still in its infancy.
Oh, I see. So it's essentially like building a massive multi-lane highway just before the city's population explodes.
Exactly.
Like we're laying down new lanes or charging ports slightly faster than the cars are rolling off the assembly line to fill them, which totally explains that Q1 dip.
Yep.
But looking at this critically, I mean, is this localized overcapacity just healthy future-proofing, or is it a flashing warning sign for the industry?
Well, I mean, from the perspective of the driver, it's fantastic.
Sure, less waiting.
Right. A 15 to 16% utilization rate means that when you pull up to a station, you probably aren't waiting in a long line behind 3 other cars. It basically guarantees a smooth consumer experience.
That makes sense. But what about the companies?
The economics behind that number are absolutely brutal.
Because if a charger is only being utilized 15% of the day,
Yeah.
that means for the other roughly 20 hours, it is just a very expensive piece of metal depreciating in the sun.
That is exactly the problem.
Yeah.
The industry consensus right now is that an operator really needs to push past 20% utilization to make the math work on a high-power DC fast charger.
Wow, 20% just to break even.
Roughly, yeah. Because these machines, they are incredibly capital-intensive to build, install, and maintain.
Which means if the macro infrastructure is booming, but the utilization rate is hovering around 15%, the companies operating these networks are just bleeding cash.
Bleeding cash is an understatement.
And that transition actually brings us straight into our second source, the 2025 annual report from Blink Charging.
Yes, let's talk about Blink.
They are one of the legacy heavyweights in this space, right?
Right.
They've got, 66,350 chargers on their network.
Yep, a massive network.
Now, most of those are those slower level 2 chargers we talked about earlier, but they also run about 1,920 DC fast chargers.
And when you open up their Form 10K, the financial reality just hits you like a truck.
It's rough.
It is. Despite the massive industry expansion and, record charging sessions nationwide, Blink posted a net loss of $83.4 million in 2025.
Wait, $83 million lost during a boom year.
During a record boom year.
It's wild. But, I mean, when you look at what it takes to actually manufacture physical hardware, it starts to make sense, doesn't it?
Oh, totally. You're dealing with supply chain volatility, the cost of raw materials like copper.
And then once the machine is actually in the wild, you have weather degradation, software glitches, vandalism.
Right. Hardware is just a race to the bottom. The margins are razor thin.
Yeah.
And the technology becomes obsolete the second a competitor builds a machine that can push, 5 more kilowatts.
So how are they dealing with that?
Well, Blink looked at that $83 million crater and realized they couldn't just keep doing the same thing. They had to launch a massive restructuring.
Which they branded the Blink Forward initiative.
Right, Blink Forward.
Which, I gotta say, the branding sounds very corporate and optimistic, but the execution was ruthless.
Very ruthless.
They slashed their global workforce by about 40%. They dropped from 513 people down to roughly 320.
Huge cuts.
But the most radical move wasn't even the layoffs. It was the fact that they entirely outsourced their hardware manufacturing.
Yes.
Like, as of early 2026, Blink does not build its own physical chargers anymore.
It is a profound pivot. By outsourcing the metal and plastic, they instantly reduce their fixed overhead. They are basically abandoning the factory floor to become an owner-operator.
You know what it reminds me of?
What's that?
The video game console industry. Like the PlayStation model.
Oh, that's interesting. How so?
Well, Sony often takes a loss on the physical plastic box you put under your TV, right? They don't really care about the hardware margins.
Right, they sell it at a loss.
Exactly. They just want the box in your house so they can charge you for the monthly network subscription, the digital game downloads, the microtransactions for the next decade.
Ah.
Blink is doing the exact same thing. They're becoming the cell phone carrier of EV charging.
That is a flawless comparison.
They don't care who makes the physical tower. They just want to own the transaction every single time you plug in.
Exactly. And their recent acquisition totally proves this strategy.
Right. They bought a company called Zemetric.
Yes. Now, Zemetric did bring a new, cheaper Level 2 charger called the Shasta into Blink's portfolio. But the real prize wasn't the hardware.
It's software.
It was the software. Blink bought Vital Fleet and energy management architecture.
Because software is where you can actually control the economics.
Precisely. You can dynamically adjust pricing based on peak grid hours.
Oh, right.
You can charge idling fees if someone leaves their car plugged in too long, and you can manage bulk billing for commercial fleets.
So how does Blink actually deploy this software-first strategy out in the real world?
Well, they offer 3 main ownership models to property owners.
Okay, break those down for me.
The first is host-owned. This is where the property owners say, a shopping mall, they buy the equipment outright, they pay for the installation, and they keep the charging revenue.
So what does Blink do in that case?
Blink just provides the software network and maybe a maintenance plan. They collect a fee for that.
Got it. What's the second model?
Then you have the hybrid model. This is where Blink pays for the charger itself, but the mall pays to install it, and then they split the revenue.
Okay, that seems fair. And then there's the third model, which they call the turnkey model. And this one is fascinating. This is where Blink pays for absolutely everything. The hardware, the installation, the maintenance, the grid connections.
Everything.
But in exchange, Blink keeps substantially all of the charging revenue. And here's the kicker. They lock the property owner into a contract that can last up to 27 years.
27 years of captured revenue.
I mean, that is a lifetime in the tech world. So if I'm tracking the logic here, this is why they don't care about manufacturing anymore.
Right.
They are playing a massive land grab game. They want to capture prime real estate like grocery stores, airports, municipal parking lots before any other network can get to them.
Exactly.
Because if they can lock down that parking space for a quarter century, that is how they eventually overcome that $83 million deficit.
They secure geographic monopoly.
Right.
But, executing that turnkey model exposes the deepest flaw in the entire EV transition.
Which is...
Well, securing a 27-year contract on a piece of paper is easy.
Yeah.
Actually, putting a high-powered charger into the ground is an operational nightmare.
Oh, yeah. Because you aren't just like bolting a box to the sidewalk.
Not at all.
You have to physically connect it to the municipal power grid. We are talking about major trenching.
Yep. bringing in heavy machinery to cut through asphalt,
Yeah,
sinking deep
yeah.
trenches.
Laying heavy-duty conduit, pouring new concrete. It's a whole construction site.
And that's just the physical labor. The bureaucratic nightmare is actually worse.
Really?
Oh yeah, you're waiting on city permits, environmental reviews, and the biggest bottleneck of all, the local utility company.
Why are they the bottleneck?
Because if you want to drop 4 250 kilowatt chargers in a parking lot, that requires a megawatt of power.
Wow, a full megawatt.
Yeah, and the local grid probably can't handle that right out of the box.
Yeah.
So you have to basically beg the utility to install a new transformer.
And how long does that take?
It could take 12 to 18 months.
18 months just for a transformer? That is an agonizing delay.
It really is.
I mean, imagine being a logistics business, right? Like a delivery fleet, and you have a corporate mandate to electrify your vans.
Right, you've got ESG goals to hit.
So you buy all these electric trucks, but you can't actually use them because you're waiting a year and a half for the city to approve your trenching permits.
This is paralyzing.
Which is why some companies are just giving up on the permanent grid entirely. And that brings us to the third source, which I think is the most fascinating shift in the landscape, Exos.
Yes, Exos is attacking the infrastructure bottleneck by simply bypassing it altogether.
I love this. So they were founded in 2016, right?
Correct. And they originally made their name building electric commercial vehicles, like the big step vans you see delivering packages for FedEx or Lonas.
Right.
But they realized their customers couldn't charge the vans for the exact reasons we just talked about.
The delays.
Exactly.
Right.
So Exos just started building mobile charging infrastructure themselves.
They recently rolled out their newly expanded Exos Hub lineup, which, honestly, these are essentially massive power banks on wheels for commercial trucks.
That's a perfect description.
Just like you might carry, a little portable lithium-ion battery in your backpack to charge your phone when you're stuck at an airport without an outlet.
Right.
Exos is building the exact same concept, but scaled up to the size of a trailer.
And the specifications on these hubs are incredible. They offer 3 capacities: 210, 420, and 630 kilowatt hours.
Okay, now earlier we talked about kilowatts as the speed of the charge.
Right.
But kilowatt hours are kilowatt hours that measures the total volume or capacity of the battery, right?
Exactly. So a 420 kilowatt hour hub holds a massive reservoir of energy.
And the starting price for these units is about $158,000.
Which, on its face, sounds like a huge capital expense.
It does. But if you compare it to the nightmare we just talked about...
Right, the trenching through asphalt, buying transformers, waiting 18 months.
Yeah, that $158,000 sticker price is suddenly an absolute bargain.
It really is. Because the core benefit of the Exos hub is zero.
Zero what?
Zero trenching. Zero permits. Zero utility delays.
It's instantaneous infrastructure.
Exactly. You literally buy it, park it in your lot, and plug your fleet into it the same day it arrives.
That is wild. And the engineering behind the mobility is brilliant, too.
Oh, it's very clever.
Let's look at the middle tier unit, the 420 kilowatt hour hub. The specs say it weighs just under 10,000 pounds.
Yes, and that is a very specific, intentional engineering target.
Why is that? Because it means you don't need a semi-truck or a driver with a commercial driver's license to move it, right?
Exactly the point. Anything under that 10,000-pound threshold can be hitched to a standard 3/4-ton pickup truck, like a Ford F-250.
Oh, wow.
So any regular employee on your staff can tow this massive energy reservoir to wherever it is needed.
And yet, despite being that portable, that unit holds enough juice to charge 15 to 20 commercial delivery vans per cycle.
It's extremely dense power.
And if you're running a massive logistics depot, you aren't even limited to just one, are you?
No. The company notes that up to 10 of these hubs can be daisy-chained together.
10 of them.
Yeah. You can link them up to create a microgrid, providing over 6 megawatt hours of power.
That is insane.
You just need a single low-power tie to the building to slowly trickle charge the hubs overnight or, during off-peak hours.
And then they just dump high-speed DC power into the trucks when they return from their routes.
Exactly. It fundamentally changes the calculus of fleet electrification. A logistics company can start running zero-emission routes today without waiting on the local utility.
And if their lease ends or they move to a bigger warehouse, they don't have to leave their expensive charging infrastructure behind in the concrete.
Nope, they just hitch it up and tow it to the new location.
That is so smart. Now, if this technology is highly efficient for package delivery, it is absolutely critical for national security.
Ah, yes. The military application?
Right. which is why the military is getting heavily involved. The recent news reports detail how Exos is demonstrating this mobile technology live for the U.S. Air Force Global Strike Command down in Louisiana.
And the Air Force, they understand the vulnerability of being anchored to a fixed, fragile electrical grid better than anyone.
Definitely.
They operate incredibly power-constrained facilities, and they have remote field deployments where running a permanent, hardwired grid connection is either physically impossible.
Or strategically dangerous. A fixed power station is just a fixed target.
Exactly.
And, this connects back to you, the listener, in a very tangible way, too, because we all rely on resilience.
Right.
Think about emergency response. Say a hurricane rolls through and wipes out the municipal power grid for a week. The gas stations can't pump fuel because they don't have electricity. So how do the city's electric ambulances or police cruisers or utility trucks keep operating?
You certainly can't wait for the grid to come back online.
Exactly. But with this technology, a city can just hitch a 630 kilowatt-hour Exos hub to a pickup truck, tow it straight into the disaster zone, and set up an instant high-power gas station for emergency vehicles.
It bypasses the structural bottlenecks that normally slow down the transition, but more importantly, it builds decentralized resilience into the whole system.
You are no longer entirely dependent on the grid functioning perfectly at all times.
Right.
So, synthesizing everything we've looked at today, we are witnessing an industry that is attacking the infrastructure problem from 3 completely different angles simultaneously.
We really are.
We have the macro reality shown by the Perrin data, this record-shattering brute force build-out of massive high-speed public chargers that drivers are actually actively utilizing.
Then we have the corporate evolution, exemplified by blink charging. That painful realization that hardware is a financial sinkhole.
Right.
Forcing networks to fire staff, outsource manufacturing, and pivot entirely toward software and long-term real estate capture just to survive the economics.
And finally, we have the off-grid bypass from Exos, the realization that sometimes the most efficient way to interact with the grid is just to detach from it entirely.
Yeah. Utilizing mobile power banks to instantly spin up infrastructure wherever it is needed without waiting for a single permit.
It is an incredibly dynamic ecosystem that is maturing so rapidly. I mean, the growing pains are real, but the solutions are highly innovative.
They really are.
Which leaves us with a fascinating concept to chew on as we wrap up this deep dive.
Okay, let's hear it.
We are so conditioned by the 20th century model of the gas station, right? It's a fixed piece of real estate, pouring concrete over a corner lot, and forcing all the traffic to come to that specific point for the next 50 years.
Right, it's very static.
But if mobile hubs can be daisy-chained to provide massive megawatt-level power anywhere, what if the gas station of the future isn't permanent at all?
Oh, that's a profound shift in civic logistics.
Right.
Instead of fighting for prime real estate, what if fleets of autonomous mobile chargers are just dynamically deployed based on algorithmic demand?
Exactly. They roll into a stadium parking lot for a Sunday football game, provide massive charging capacity to thousands of fans, and then they just tow themselves away on Monday morning to support a logistics hub across town.
The infrastructure becomes entirely fluid.
The gas station comes to where the traffic is instead of the traffic going to it.
Wow.
Thank you so much for joining us on this deep dive. Keep questioning the headlines, keep looking beneath the surface of the data, and we will see you next time.